when we come across our different distributions, we're always going to come across questions that require going backwards, and these are called inverse distributions. So this will be going over inverse binomial distribution. I've written up the formula for a normal binomial distribution, and inverse means now instead of trying to calculate the probability, you already know it, and you're trying to calculate either n or pi. For an inverse binomial to work, you need to know either the probability that x equals 0 or the probability that x equals n. And the reason for this is that we have two parts that have pi in it, so if we're not able to get rid of one of those, then it'll be quite a complicated solve. However, if x equals 0, then in the first part we have pi to the power 0, which is just 1, and so that whole term will be gone. And if we have x equals n, then in this part we have 1 minus pi all to the power of 0, which will then be gone, and so then we can solve a bit easier. We're going to look at one big example to see how this works. A company sells packets of 10 USB drives. As soon as I read that, I'm thinking n equals 10. Customers return 14.9% of packs because their pack contains at least one faulty drive. Calculate the percentage of USB drives that are faulty. So the most common mistake is not realizing what is pi and what is a probability, as in p, as in the big P up here. We never really look at a probability of, in this question, 14.9% of packs because their pack contains at least one faulty drive. When it says at least, we don't know what that means. It could be 1, 2, 3. And so that's going to be the probability that x is greater than or equal to 1 equals 0.149. That's the only thing it can be, just because we don't know what at least 1 means. That means that probability x equals 0 will be 1 minus 0.149 or 0.851. And what this is the probability that no USB drives are faulty. I find it helpful to write down what the probability means, just so I can get in my head what I'm trying to work around. So now trying to answer this question, we know that n equals 10, x equals 0, and the probability that x equals 0 is 0.851. So substituting this into our formula, the one up here, we have 0.851 equals 10, 0 times pi to the power 0 times 1 minus pi to the power of 10 minus 0. Now you can do the thing in brackets, 10, 0. You can in your calculator use the combinations formula, or you can realize that that is just n factorial over n minus x factorial times x factorial. So in this case we have that is equal to 10 factorial over 10 minus 0 is just 10 factorial times 0 factorial times 1 minus pi to the power 10. Well, this whole part here is 1. And so we have 0.851 equals 1 minus pi to the power 10. Solving, we can take the 10th root of 0.851 or 0.851 to the power of 1 over 10. We get 0.984 equals 1 minus pi. Solving for pi, you get 0.016. So the question is calculate the percentage, and so the percentage is 1.6% are faulty. Okay, next question. The company would like to reduce the number of packets of USB drives returned to less than 10%. given that they use the same USB drives, calculate the maximum number of USB drives that each packet will have. So now it's pretty clear that N, we don't know what that is. From the previous question, we know what pi is. We know that the probability that a USB drive is faulty is 0.016. And we know that we want the probability that a packet is returned, i.e. the probability that x is greater than or equal to 1, to be less than 0.1. That's what we know. Now we need x equals 0, so that means that the probability that x equals 0 must be greater than 0.9, which means that now in our calculation x equals 0. So substituting all of this into our formula, we know that we don't know what n is, so that's n0 times 0.016 to the power x is 0 times 1 minus 0.016 to the power of n minus 0, and we know that that there must be greater than 0.9. Okay, so because we have n in our combinations part, we can't use our calculator, we have to use the formula. So that's n factorial over n minus 0 factorial, which is just n factorial times x factorial, which is 0 factorial, times 1 times, and 1 minus 0.016 is 0.984, which is the power of n must be less than 0.9. Okay, n factorial over n factorial times 0 factorial. Well, since 0 factorial is 1, this is just n factorial over n factorial, which is 1, which means we have 0.984 to the power n must be greater than 0.9. To solve this, we can log both sides. Bring the n to the front of the log. And then divide by log of 0.984. Now log of 0.984 is a negative number. It's very important to realize that when you log any number between 0 and 1, greater than 0 and less than 1, you get a negative. Which means when we divide by this, we have to flip our sign. We're left with n is less than 6.532. Now we want the maximum number of USB drives, so the maximum number will be n equals 6. The maximum in each packet is 6. Finally, calculate the percentage of new packs which will be returned by customers because they contain faulty USB drives. Remembering, for something to be returned, that means that we need probability that x is greater than or equal to 1. We know that n is now 6. We know that the pi is from before 0.016. To calculate probability that x is greater than 1, we need, that's what we equal 1 minus probability that x equals 0. And so x will be 0. Chuck that into your calculator, you get 1 minus 0.9078 or 0.0922, which gives you 9.22% returned, which is good because originally we wanted it to be less than 10% from part B, so we're pretty confident that we have done this all correctly.